My name is Holger Litters from HTW Berlin, University of Applied Sciences. We are happy to get in touch with new ideas on a regular basis. Oculid is one of those ideas, a startup that creates a new kind of technology in the field of eye tracking. I have been working with Oculid in several research projects already, and I guess it is time that others understand this approach too. So let us first have a look at the development in the field of eye tracking until today to better understand the advantages and some of the disadvantages of this specific idea. Eye tracking has always been a fantastic opportunity in the world of market research. It was just a little complicated for the average researcher. The last decades have shown tremendous progress in the technical development. Hardware has constantly become better and cheaper. But we all learned that hardware is only one part of the necessities in eye tracking research, as analysis software is getting more and more important in the process. The technical development in eye tracking often pushes decision makers into some kind of trade-off decision between quality, time, and estimated cost of research. Some argue that the technology of infrared eye tracking is better compared to, for example, webcam eye tracking. Perhaps this is true, but as literally no individual owns a private eye tracking device, those high-quality studies need to happen in the lab, adding to time and cost of a study while not being able to sample specific people across the country. With webcam eye tracking, random people can potentially participate in an eye tracking study and do not need to come into the lab. The pandemic has even added to the technical equipment of people, as nowadays nearly every computer at home is equipped with a webcam. But this comes at the cost of perhaps lower quality of the device setting of someone back home. So webcam eye tracking solved one major issue in research, bringing up other new issues. We live in a mobile-first world. As the usage of mobile phones becomes more and more important, we are kind of stuck between the different technical approaches for eye tracking. And eye tracking is definitely needed for mobile devices too. On the left side, you see an innovative approach of using the full classic equipment of remote eye tracking to observe someone's eyesight while using a mobile device. It is a clever workaround, but it still requires the entire tech set of a remote tracking device, and still the participant needs to come into the lab to perform those tasks. On the right side, you see a technical device helping to improve eye tracking on tablets by the hardware supplier Tobii. Nice solution for this new problem of tracking people during mobile usage. All these approaches require specialized hardware, and participants cannot do this from their own home. It also brings the negative aspect of a controlled environment where participants might feel less free in their behavior. The first smartphone with a front camera, also called selfie cam, was the iPhone 4 in the year 2010. The development of the selfie cam became a hardware battle, as this seems to be a major feature for the younger user. Apparently, some influencers value the selfie cam more than the classic camera. The fun part, people already own those cameras and can use them for market research too, while performing a task on their touch device in a very natural environment while being eye tracked. BYOD, bring your own device, is the strategy when implementing this fact into your research. And the smartphone market stays much more up to date than you could ever do with your research equipment. 60 million smartphones in Germany with a replacement rate of 30% per year means that this is a key argument for representative market research using eye tracking with the selfie cam. And you don't need to update your own research equipment, as people do this on their own. Germany is behind the international development of mobile internet usage. But with more than 52% access to the internet on a mobile device, we're talking about the majority. 4 out of 5 people in our country use the internet in a mobile version on a regular basis. The near future will definitely be mobile. Some app producers even force us to use a mobile phone. Get the app is a magic way into pure mobile usage. This is what you can experience with Snapchat or other services. So I guess we need some fresh thinking when integrating this mobile world into eye tracking research. This is why the Oculate approach is an idea that could perfectly fit into our time and our future.
In the following section of our talk, I'd like to present Oculate's platform to you that allows you to run eye tracking studies on smartphones from the comfort of participants' homes. With our platform, we support companies in understanding how their customers engage with their digital product, campaign, or brand on mobile phones. The platform can be used to test anything from advertisements to videos, shopping tasks and packaging, as well as mobile web usability. Within the platform, you can design a test within minutes by specifying the tasks and the material that you'd like to test. You can select the Thinking Out Loud method and integrate external surveys and questionnaires. You invite participants who run the tests from their homes using their own smartphones. As soon as the first person has uploaded their data, you can start the analysis in the platform, which enables you to complete a study within days. Subsequently, we will present 2 showcases to highlight some areas of application for smartphone eye tracking. These examples are placed within the context of online marketing and from online shopping. In the first showcase, we collected data of 10 German testers within the course of a day. All testers were asked to study 4 campaign images on their phones for 10 seconds. Subsequently, they were asked how sustainable they thought the displayed products were. The study was implemented within Oculate's platform by specifying relevant screener questions and the tasks when viewing each image. We then uploaded the images and implemented a rating of the product. Invitations were sent to possible participants. Participants opened the key to the study in the app and consented to the recording of their screens. They received brief information with regard to the eye tracking and in particular with regard to the positioning in front of the screen. To calibrate the eye tracking to the individual participants' properties, a dot moved to 13 locations on the screen and the participants were asked to follow it with their eyes. The calibration was uploaded to our servers and the quality was checked. In case of insufficient quality, the calibration was repeated. Then the actual task started. We analyzed which campaign images were rated highest with regard to sustainability. Additionally, we evaluated if the campaign messages were indeed read by the participants and if they were compared to the brand that ran the campaign. This was true for the highest rated image. This can also be displayed in individual recordings for each participant. The second use case that I would like to present is a study conducted by iSquare using Oculate's smartphone eye tracking technology. The study used smartphone eye tracking and in-real context testing. The testing was done by 100 respondents across the United States, with samples being collected during 2 days. Each tester was given 3 to 5 minutes to complete each test. 3 scenarios were included in this study: an online shopping scenario, a packaging scenario, and a scenario where an advert was tested in context. In this talk, I focus on the advertising scenario. As part of this scenario, the participants were asked to complete 2 tasks: viewing a video advertising on Instagram and later shopping online for the product shown in the video using a smartphone device. The analysis was completed using Oculate's eye tracking software combined with iSquare's in-context research. The analysis of the eye tracking data revealed that the product displayed in the video advertising received more visual attention than the products from competitor brands. The advertised product received 2.4 seconds of visual attention as compared to 2.1 seconds from the closest competitor. This was true even though the researched product was listed as fourth in the online shopping platform. In addition to receiving longer views, customers showed 50% more interactions, thus clicks or taps, with the advertised product.
Even though I'm excited about the idea and the Oculus system itself, we still need to critically evaluate the status quo of the Oculus approach. Bring your own device strategies always become a challenge. We have to deal with the same issues as webcam eye tracking. The Oculus system is a mobile testing system which makes it perfect for everything that happens on mobile devices. The setup online is nice and easy, and the integration of questionnaire tools before and after the process of eye tracking allow you to combine your research approaches with third-party tools. I like the Think Aloud feature very much, as it is very helpful in usability testing. The negative aspect is the necessity to install an app on someone's device, allowing the camera and the microphone to track things. I guess this can only be solved by incentives or extreme motivation. It has, by definition, nothing to do with the technology itself, but it needs to be solved. Also, we are talking about much more data that needs to be processed with this system. Therefore, we depend on the user's internet speed, as a lot of data needs to be uploaded after the process of eye tracking. You need to be aware of this, and this can also be solved in prior testing. For the time being, the most inconvenient disadvantage is the lack of support for iOS devices. Until promised me that this is going to be taken care of in the near future, so we're looking forward to have a real representative opportunity in mobile.
Last, I'd like to pick up some of Holger's cons and give a brief outlook into the future. As Holger, we believe that it is very important that testing is possible on all phones, so we aim to complete an iOS test app within the upcoming months. We also aim to include tablets and enable testing of native apps, as it is currently limited to images, videos, mobile websites and prototypes. We are also in the process of integrating more test panel providers and automating the detection of areas of interest. Thanks a lot for your attention. We are looking forward to a lively discussion.